All right, so we are now going to look at mucking, mucking, mucking. So others also call it bogging, mucking or bogging. This is a process of loading or cleaning up or removing the part of broken material or dirt into trucks. Nti mucking ni nyinaa ne sɛ yɛablase awie na yɛresesa ore no de agu dump trucks no de akɔ. That is what we call mucking. That's what we call mucking. Or sometimes they call it bogging, especially in underground. That is why they call that machine bogger. Bogger no dey bogger no dey yes, kakraka ɛsesa material no. So what is that material no? De agu dump truck no a, that's what we call mucking. You are mucking or you are bogging. Now we have overbreak or excessive break. Let's just say overbreak. It's simple. A rock beyond the desired excavation limits. So this too, let me use a diagram to explain. Let me use a diagram to explain the overbreak. Yes. So we are going to blast. We are going to blast this square pattern. Yeah, design a blast. Let's say there's one hole here. There's another hole here. There's another hole here. There's another hole here. If it's a square pattern, you bring the next hole here. If you're not doing square pattern, then you're using staggered. In between these two, the next you put a hole here. Good. So let's say I am designing a staggered. So I have my first hole here. Second hole is a blast hole. So if I'm designing staggered, in between these two, I'll put one here. I'll put one here. If I'm coming the third row, I'll put one here. In between these two, I'll put one here. And then let's say I put the last one here. It's okay. I've designed the last hole. I have a hole here, I have a hole here, I have a hole here. Now, the design is in such a way that we want to fire up to this limit. And a person a fireman at the if we throw the blast at the end of the day, now people say this is where we are saying, okay, let's put human errors. So human errors, if I said human errors are also, let's say it should break up to this session. But in some cases, you see that instead of here breaking, it will extend to, let's say, this session. Now, when this happens, we call it overbreak or back break because we don't need this session to break. And normally, that is where the what do you call it? The borders comes from. So any break beyond the desirable excavation is what we call the over break of a it is the breakage of a rock beyond the desired excavation limits. Let's say that we've designed this blast. We want to break up to this session. Can a person a fireman drew? This is the final session. Now, if you fire or if you throw the blast and then it's the breakages exceed this limit, exceed to let's say this part, then we can say overbreak has occurred. All right. So the powder factor is a term that we use to describe the mass of explosives used to break a unit rock. Yes. When we talk about powder factor, a amount of explosives I did hole BM. We're supposed to do a compare hole BM. That is the powder factor. So it is used to describe the explosive used to break a unit volume or weight of a rock. So the amount of explosives needed to break a volume of a rock is what we call the powder factor. All right. So the powder factor, it is a term that we use to describe the mass of explosives used to break a unit volume or weight of rock. So the amount of explosives at the explosive track in ABC drilling pattern. So let's say MMU, we call the explosive track MMU, mobile manufacturing units. So ABC wa who be amount explosive don't pump people who be and then I find the powder factor. It is the explosive required to break a unit of what? Rock. If you don't get the right powder factor, Well, you are causing financial loss to the company because these explosive companies, the amount of explosive that they pump in, that is what they charge the company. That is the first thing. So we have explosive company, we have Orica, we have ACIL, we have is it Saviok? Well, yes, they're all explosive companies. Now, if you don't calculate it very well, the impact will be too much. So let's look at certain things that causes the overbreak. The timing, the firing sequence, all of them can affect the. Yes, I'm going to design a blast. Let's say I have this. Let's say we have holes here, drill holes you are going to fire. I have holes here I'm going to fire. Now, do you know we time the holes, the amount of time I ever fire. So let's say the first hole that you call it IP, the initial point, we give it 0 milliseconds. Internal there, umi on same fire, now umi attack and so that will go first. Boom. Now from here to the next hole, let's say 17 milliseconds. 17 milliseconds, 17 milliseconds. Now, if you're moving from this row to the next row, you can use, let's say, 42 milliseconds. So, if you close up the firing time, if I say so the 17 milliseconds, the go after the 17 milliseconds, how about go? When designing the year, you get SS break because at the airbag, I had the speed, boom. Next line airbag, boom, airbag. But if you increase the timing, quantum, you get SS break because the energy that it is coming, no, it is directly proportional to the timing sequence now, man. You get it? That is one. And then the another factor is the powder factor. If you pump in too much explosives, the energy will be too much. You will not even get the rock size that you need. You rather get fines. People say, "Oh, blastis kapani is kind of powder." Because at the end of the day, we need money to run. So the powder factor is a very critical thing. If you are a mining engineer and you are designing any blast, you should look at it very, 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 very well. Sometimes it's also have influence, or it also has some connection to do with the hardness of the rock. If the rock is too hard, you pumped in a lot of explosives. And then even with the explosives in Bukla, we have the primary explosives and then we have the secondary explosives. You have the boosters and then the detonators. In drill and blast class, the lecturer will take you through. I think you are going too much into drill and blast. But I hope the powder factor is well understood. All right. So we're going to look at the unit operations in mining. The unit operations in mining. Now, what is unit operations in mining? The unit operations of mining are the basic steps employed to produce mineral from the deposits, as well as the auxiliary operations. Now, so anything, all the things that we do in the aim of bringing the mineral out of its natural state, that is what we call the unit operations. So we have the unit operations. All right. Sorry, let's continue. So they are the basic steps employed to produce mineral from the deposit, as well as other auxiliary steps involved. So all the things that we do to bring the mineral of interest out is what we call unit operations. So those steps that contribute directly to the mineral extraction process are production operations, which comprise the production cycles of operations, while auxiliary steps that support the operations cycles are called the auxiliary operations. Now we have this unit operation, it has been divided into two. We have the production operations and then we have the auxiliary operations. Now, when we talk about the production operations, what it means is that they are all the things that have direct impact to the mineral extraction. They are steps that contribute directly to the mineral extraction. So then look at the money at the directly, you know. That is what we call the production operation. And then the auxiliary operations now the mineral of interest. So let's say the production cycle employs unit operations that are normally grouped into two functions. Now, you can say production operations. Now, make us say they contribute directly to the mineral extraction. They are into their focus is how we can get the ore out, and that is how a mining engineer thinks. Production. Yes, that is the production operations. So everything with regards to production, everything that leads to the money or the ore, that is what we call the production operations. So the production operations have been further divided into two. We have the rock breakage and the material handling. When we talk about the rock breakage, That's a way of re-breaking the rock down. That is where you can say drilling and blasting. So drilling and blasting is part of the production operations because they have direct impact on the mineral extraction. If you don't drill and then you don't drill and blast, you are not going to get the mineral of interest.
Mhm.
Good. So drilling and blasting is part of the rock breakage. Let me start from the production operations. The production operations, they are the operations that have direct impact on the extraction of the mineral. In terms of their focus is on the extraction, how to get the ore. And these production operations have been divided into two. We have the rock breakage and then the material handling. So the rock breakage is all the activities that involve of just re-getting the ore or we getting the rocks being breaking down from their natural states. And then the material handling is after breaking it, after doing the drilling and the blasting, the materials cannot walk to the processing plant for you to get the money. You have to load and haul. That is why somebody said the load and haul units. So this production, sika production, no, my car production, sika na say a juma nankasa so no. That is the drilling and blasting, and then the loading and the hauling. They form the production team. So because the co-production meets now, you see drill and blast engineers, drill and blast managers, and then you see the load and haul engineers and load and haul managers too. They also join. So the production is we breaking the rock and then taking the rock from where we fired to the location where it's supposed to be.